If an operation can be performed in m number of ways, and a second operation can be performed in n ways, then the total number of ways to perform the sequence of two operations is m times n. In general, if a sequence of several operations is to be performed, the number of ways to perform the sequence is found by multiplying together the number of ways to perform each operation. So this is a good way to find your sample space and find the number of ways something can happen. So a certain make of automobile is available in any of three colors, red, blue, or green, and comes with either a large or small engine. How many ways could someone buy that car? Well, we have the number of colors and we have the size, right? So the number of ways we could buy it, there's three colors and there's two sizes. So there's 6 different options we could have. License plates in a certain state contain 3 letters followed by 3 digits. So 3 letters and 3 digits. When we're talking about the letters, we're talking about the letters in the alphabet. So there's 26 letters. So 26 times 26 times 26. Now, it would be different if they said they couldn't be duplicated. This one didn't, it just said that it could be any 3 letters. Now, the 3 digits, 0 to 9, that's 10. 10. So the number of different ways we could do a license plate would be 26 times 26 times 26 times 10 times 10 times 10. Wow. 17,576,000 ways to make a license plate. This is called the fundamental principle of counting. This is a way to count how many options you have, like, ways to order a pizza, that type of thing. Now, when we talk about permutations, the word permutation is another word for ordering. When we count the number of permutations, we are counting the number of different ways that a group of items can be ordered. It's a little different. So the permutation of items if we have a set of n objects, the way we find the number of permutations would be by taking the total number of objects, and we placed 1, so we have 1 less times 1 less from that. This is the technical way of doing it, times 1 less than that. Dot. This is represented by n with a line. This is called a factorial. So if we had 6 items, the permutations, the ways we could arrange those 6 items, those 6 books on a shelf, would be 6 times 5 times 4 times 3 times 2 times 1. Let's look at that. We have 5 runners run a race. One of them will finish first, another will finish second, and so on. So let's think of this. So first place, how many people could be in first place? Well, 5. We already have 1 person in first place now. How many people could be finishing second? Well, 4. How many people could finish third? 3, 2, and then by the end of it, there's 1 person who's finishing last. So 5 times 4 times 3 times 2 times 1. Is 120. Now, by the way, there is on these calculators a fast way to do that. So this is technically 5 factorial. If I press the 5 and go to math, and we are doing probability, Notice that there's a little exclamation mark. That does 5 factorial. That does 5 times 4 times 3 times 2 times 1. 10 runners run a race. The first place finisher will win a gold medal. The second place finisher will win a silver, and the third place finisher will win a bronze. Now notice there's only 3 medals this time. Okay, so for first place, we have 10 runners that could get first place. Now that one of those people is already there. So how many people could get silver? Well, there's 9 left. And for third place, there's only 8 left. So notice how this is a little different. We're only picking 3 out of the 10 people. So I would just do 10 times 9 times 8. Whoops. There's 720 ways to get those first 3. Now, we had 3 runners chosen from a group of 10, then ordered first, second, and third. This is referred to as a permutation of 3 items chosen from 10. In general, a permutation of R items chosen from N items that is ordered. It is obtained by choosing R items from a group of N, then choosing an order for the R items. That's all crazy. But the number of permutations is denoted by N capital PR. That means the number of items. So here we had 10 items and we picked 3. Right? Okay. The technical formula for that would be that I would do that N factorial. I would find the whole thing of, so we're going to do our example here underneath. So 10 factorial on top. But I don't want all 10, right? Underneath is going to be N minus R. So N minus R. So 10 minus 3 factorial. Let's see what happens in this example. Well, 10 factorial would be 10, 9, 8, 7, 6, 5, whoops, times 4, times 3, times 2, times 1. But we don't want all 10 people, right? We just want the top 3. So what we're dividing by is 10 minus 3 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. What happens when I do that? All of those cancel out and I'm left with 10 times 9 times 8. Let's do an example. We can think about it both ways. 5 lifeguards are available for duty one Saturday afternoon. There are 3 lifeguard stations. In how many ways can 3 lifeguards be chosen and ordered among the stations? Well, the simple way is just to think about that I would be doing, let's use the formula though. So we got 5, pick 3. So we're going to use the formula on this one. It's going to be 5 factorial divided by 5 minus 3 factorial. That's 5 times 4 times 3 times 2 times 1. This would be 2 factorial, 2 times 1. 5 times 4 times 3. Is 60. Now on the TI-83s, there's also a way to do that in here. If I press math and get a probability, notice that that second option is NPR. We had 5 and we picked 3. Oh, it gave us the same thing. What about that other one we did a minute ago? We had 10 and we picked 3. Got the same answer. So permutations is used when we have an order to it, first, second, and third, something like that. We're placing them in an order. Now, in some cases, when choosing a set of objects from a larger set, we don't care about the order. we only care which objects are chosen. For example, we may not care which lifeguard occupies which station. We might care only which ones are on duty. So each distinct group of objects that can be selected without regard to order is called a combination. So the way I remember it is permutation is picky about the order. Combination is just a combination. So the combinations is abbreviated with an R. Now this formula gets a little bit crazier. These you can almost do without the formula. This one is a more complicated formula. These I tend to use the calculator to compute because the formula is a little bit ugly. So let's just think about whether we're going to be picky about order or just choosing. At a certain event, 30 people attend and 5 will be chosen at random to receive prizes. The prizes are all the same, so the order in which the people are chosen does not matter. So we've got 30 and we're choosing 5. I'll do it with the formula this once, but I'd have 30 factorial divided by r factorial times n minus r. So times, that'd be 25 factorial. That would take a while. Now I could use the factorial button. So I could do 30 and then go choose the factorial button divided by 5 factorial and then 25 factorial, and it gives me a really large number. But the easier way to do this is in that probability section, there was a C for combination. So 30, choose 5. So notice I use a different word. When I'm picky about order, I'm picking a certain number. When we're just choosing people, we're going to use the C, just choosing, just combining. Now the instructions to do that are on this page that we can go to the probability. It has the older notation on ours. You can just pick the one you want and then you're plugging in your values. So it makes it a lot easier. Now we can also use these counting principles to do a probability. A box of light bulbs contains 8 good light bulbs and 2 burned out bulbs. 4 bulbs will be selected at random to put into a new lamp. What is the probability that all 4 bulbs are good? Now, does the order of a light bulb matter? No. So now we need to think about what we have. So we have 8 good ones and 2 burned out bulbs. So there's a total of 10 bulbs. And we are selecting at random 4 bulbs, right? So 10, choose 4. This is the combination of the 4 bulbs chosen. So 10, choose 4. $210. Now, what is the probability that those 4 bulbs are good? Well, we need to talk about the good bulbs. We want to make sure we chose the good bulbs. So there were 8 good bulbs. And what's the probability that we choose 4 out of those 8? And what's the how many ways could we choose 4 out of those 8? There's 70 ways to choose those 4 good bulbs out of the 8 good ones. So 4 out of the 8 good ones. So we have 70 good bulbs out of the 210 ways to just randomly choose 4 bulbs. Gives me the probability that we got 4 good bulbs. That's 1/3. That's easy to do. And we're going to do a little bit more with this in class today or tomorrow.